Hello everyone. I hope you are getting the concepts of Indian geography or able to understand these concepts. And now we are moving to another discussion of Indian geography which is related to the soils of India. And this particular discussion is mainly related to some parts which are very important for prelims, such as soils and types of soils, and also mains oriented topics such as problems related to soils, various problems such as mainly soil erosion that India is suffering from, and also some topics which can be related to the soil formation that will be useful, that we'll be discussing in this topic. And the format of the topic would be, first we'll try to understand what is soil, and then afterwards we'll be discussing what are the factors which affect soils, then classification of soils in India, that is those 8 types of soils which were classified by IQRA, and afterwards towards the end we will be looking at some problems, soil related issues. So let's start what is soil. So when I ask people what is soil and have you seen soil, so people start laughing like they start laughing that say ki, we know soil, like what kind of question is this? But then again I ask everyone, I'm asking you people as well, have you seen soils? And I'm sure 90% of us do not really understand soils. 90% of us may not have seen soils in detail. Because the soil that we use in India, the term that we use for is mainly for dust. Right? The particles which keep moving here and there. जिसको कहते हैं मिट्टी उड़ रही है या मिट्टी है, तो that is not actually soil, that is dust which comes along with your shoes and which comes along with your clothes, etc., or which keeps moving here and there. That's dust. When I refer to soils, we mean a huge crumb of soil which can be at places deeper than 1 feet, 2 feet, or maybe more than that. It can be like 3 feet deep, or somewhere where it is very young soils, it can be just a foot. So that is what is referred as a soil, right? That entire structure is called as soil, not the one that we see on the upper part, just that loose particles scattering here and there or moving here and there with wind, etc. That's not called as soil, that's dust. So then how do we define soil, and what are the we can say characteristics of soils, or what are the components of soil? Let's have a discussion on this. So how do we define soils? It is, you can say, uncompact, right? Uncompact part of lithosphere, uncompact part of lithosphere, or we can also use another term, unconsolidated part of lithosphere. So you should understand that's disintegrated, that's broken down, right? Unconsolidated part of lithosphere having organic and inorganic matter, right? Now capable of supporting growth of plants, okay? Capable of supporting the growth of plants. That is how we define soils. So uncompact part of lithosphere having organic or inorganic minerals capable of supporting growth of plants. That is how we define soil, right? So it looks very bookish, kind of a definition, but that is how the soil is, right? When I define soil, when we look at soils, now imagine The same carbon is present in soil, and when it enters the plant body, see the difference. When the carbon or nitrogen or hydrogen, any matter for that matter, is present on the soil, it's inorganic, it's non-living. But the same carbon, when it enters in the plant body, it is organic. Right? It's a part of the living world. So the soil is that interface. If I see, define this in different terms, little more philosophical aspect, the soil is that interface where inorganic, or what you can say, non-living, inorganic becomes organic. Inorganic becomes organic. That is the interface. So nitrogen we add, urea we add to the soil, right? We add phosphate, we add any mineral to the soil. It's inorganic. But then when it enters through the soil to the plant body, it becomes organic. So that is the significance of soil for the living world, right? For the biogeography, entire biosphere, that is the significance of the soil, that it makes non-living living. It makes inorganic organic. Right? So how important is the soil? And when I say this as uncompact part of lithosphere, understand it does not have the lithosphere only. Let's see what is there in the soils and what are the different aspects of soil. Let's say if this is soil, right, this is soil, suppose it has a component of lithosphere in between. It has a component of lithosphere in between, right? Because after all, it has nitrogen, right? It has phosphate, it has other minerals. Where do these come from? These come from rocks. These come from rocks, and rocks are the part of lithosphere. It also has pores, and pores have gases. Where do these gases come from? Pores have gases like the atmospheric nitrogen is present, oxygen is present, water vapor or moreover the carbon dioxide is present, methane is present. What are these? It's a part of atmosphere, right? Atmosphere. Now it also has a component of hydrosphere. Do I need to explain this? It has a part of hydrosphere as well. Why? Because there's water. There's water. So soil is not just a lithosphere. It's a representative of a biosphere where all the three components meet. Gases present in the soil pores, moisture present in the like in the water, vapors are present, water is present, moisture is present in the in soil. So we know that there's a part of a hydrosphere, and then so many organic inorganic compounds are present, that is rock derived minerals are present, part of lithosphere. So it is alone does not represent lithosphere, it also represents other factors, right? So soil is very important as it is the interface. That's why I said where inorganic becomes organic or non-living becomes living. That is how soils can be identified, and that is how soils can be understood. Right? So when I look at the soil, that is the picture that comes to the mind, that it's a huge crumb. Now next time when you look at soils and go to an agriculture field and dig deeper, and you can see every component is represented there. Right? This is how we define and this is how we see soils. Now the question is, what are the factors which affect soil formation? Now before I go to the factors directly, one point, that the process of soil formation is called as pedogenesis. The study of soil is called as pedology, and the soil of, now the formation of these, process of the formation is called as pedogenesis. So what includes pedogenesis? And as we know that pedogenesis ka matlab, what, how do we understand pedogenesis? It means that formation of soil. What then should include? First process is the process of disintegration. Process of disintegration. And what do we define? What do we call that disintegration process? We call it as weathering. The process of weathering is called as process of disintegration is called as weathering, right? Soils or rocks disintegrate, and weathering we know have three components, three types. One is called as the physical weathering. Yes. Then the second is called as chemical weathering, and third is called as biological weathering. Right? Physical weathering, chemical weathering, and biological weathering. So these are first, you can say, preliminary process of soil. What is that? Disintegration. Disintegration of rocks. Then other second step involved in soil formation is transportation and deposition. Right? So disintegration is first stage, first step. Second is transportation, and lastly is deposition. There's an accumulation. But I must tell you one point here. These two steps, that is transportation or deposition, is related to transported soils only. We call such soils as transported soils. Right? Transported soils. There are some soils which are native soils. We'll take some example, like Deccan Plateau is a native region, or we can say Deccan Plateau is the best example, or black soil of India is the best example of a native soil. It has not got transported from somewhere. It has not got transported from Maharashtra, some Jammu and Kashmir or Rajasthan or other areas. In the soils of Maharashtra, Gujarat are native. It is by the disintegration of Deccan Plateau itself that we have black soil in the region. So are red soils of Jharkhand and Odisha. But when we look at the alluvial soils of northern plains, they're transported soils. So in native soils matlab which have not got transported, right? So native soils only disintegration, but in other types of soils there's transportation as well as deposition also. But even then, if this is the process, there must be some other factors which affect this very dynamic part of Earth's surface. I call soil as a very dynamic part of Earth's surface because they keep changing, right? Not the texture as such, but then the soil erosion happens, a lot of minerals get added, a lot of minerals get washed away. So let's see factors which affect soil formation. And what are those factors which affect soil formation? Let's elaborate these factors one by one. So first factor is the parent rock. Parent rock. I would compare parent rock with the genetic material. Compare with the genetic material. Why genetic material? See, what is parent rock, right? What is parent material? The material, right? Material that has disintegrated. The material that has disintegrated, that has broken down. That is what is called as parent material. So, suppose if you look at Uttar Pradesh or Bihar or West Bengal, where is the parent material coming from? Himalayas. But when I look at the Jharkhand or Karnataka or Maharashtra for that matter, where is the parent material coming from the same rock itself, from the same region itself. But if parent rock has a higher, say, calcium, soil will also have a higher calcium. If parent rock has higher, iron, then the soil will also have higher iron oxide. So that basic composition of the soil is determined by parent material. Right? This determines basic composition. Right? Basic composition. You understanding basic composition? The main constituent of the soil. So, what is genetic material? Genetic material actually controls the external appearance. Genotype depicts phenotype. Genetic makeup depicts external appearance. Exactly in the same way, the composition of the soil determines the appearance of the soil, the main component of the soil. So, parent material is very, very important. Whatever one carries in the genes, accordingly will be exhibited, right? Physical features are formed in the same way. So soil will also be, this is a very, very important factor that controls soil type and soil, you can say, texture or characteristics. Then comes the second component, and that is soils. Then second factor, that is climate. How does climate play important role? I would call climate as the most active part. Very active. If parent material will act as a genetic makeup or the genes of the soil, this climatic conditions act as cooling of the soil. The physical appearance will be determined by the genetic makeup, fine, but behavior, language will be determined by schooling, by socialization, by the place where we live. So even same genetic material but brought up in different climatic conditions will have different characteristics, even if the basic ingredients are same. How will climate affect soil type, or how will climate affect the texture of the soil? Let's discuss this factor. So I'll just briefly discuss how will climate play a significant role. Let me come to the climate first. Okay, when I see climate, what are the characteristics of climate? What are the factors that determine climate? Or if not factors, we can say what are those climatic conditions which define a climate? Rainfall, temperature, these are two main factors, right? If the temperature will be different, pressure is different, and so on, rainfall, etc. So we say that a region can be higher rainfall region or a lower rainfall region. Similarly, higher temperature region or a colder region. So here I am considering a region where the soil moisture balance, MB matlab moisture balance is positive. Soil moisture balance is positive. First factor, first condition that I am taking for. Now, how is it possible? It is possible in two cases, two ways. Number one, the precipitation exceeds evaporation, like equatorial areas, like tropical areas of the coastal areas, like Jharkhand region or Meghalaya region of India, where the rainfall is so heavy throughout the year. So precipitation is higher than evaporation, soil moisture balance will be positive, or evaporation would be very less than precipitation. Like in colder areas, like Himalayas, like polar areas of the world, temperate areas, the precipitation is not heavy, rainfall is not higher there, but evaporation is very low. So even if the evaporation is low, the soil moisture balance will be positive. Right? It's like two ways to keep your bank balance positive. Either you earn a lot or you save a lot. Right? You reduce your expenditures or you earn a lot. Exactly in the same way. So now first, in these processes, in these regions where precipitation exceeds evaporation, that means those areas where moisture balance is positive because of very heavy rainfall. What happens in this case is that there is a washing away of soils or washing away of minerals. Washing away of soils or minerals. Right? This washing away, there's a very general term for this, and we call this process as leaching. Call this process as leaching, L-E-A-C-H-I-N-G, leaching process. Right? A general term used for the washing away of soil. Right? That is the case. Let's try to understand soil type based on leaching and how actually leaching process happens and how does it give characteristics to the soil. Before I go to explanation for this, you see what are the components of the crust? Let's go back fast. Crust is predominantly made up of Cl, but we know there are other minerals also. So what are the minerals of the crust? Yes, go on. Other than oxygen, it is silica, then it is aluminium, then it is iron, right? Then there's magnesium, then there is calcium, then there's potassium, there's potassium, then there's sodium and other. And these are mainly in the form of chlorides, right? Mainly in the form of chlorides or carbonate. So we have magnesium chloride or carbonate, we have calcium chloride or carbonate, we have potassium chloride or carbonate, or sodium chloride or carbonate. They are also in the form of hydroxides. Right? So predominantly it is Cl, fine, okay, silica, aluminium. The third component or third constituent in the descending order is like iron, then it is magnesium, then it is potassium, then calcium, then sodium, and so on. Right? This is how we can understand, and we have understood this. We know that the components of the crust. Now, how leaching will affect soil type? Let's try to understand with the help of this particular diagram. Right? So I'll write down here these minerals, right? What are these minerals? Silica hai, then aluminium, then iron, then sodium, calcium, potassium, phosphates, and also magnesium, so on. Even if there is a moderate rainfall, leave about what is written here. Leave this part. Let me simplify for you. Even if there's a very moderate rainfall, by moderate rainfall I say if the region receives an annual rainfall of around 100 centimeters or so, right? Close to 100 centimeters. The first minerals which will get washed away would be sodium, because it is usually in the form of sodium chloride, calcium. All the chloride salts will easily wash away because they are soluble in water. Hydroxides will be washed away, right? Then the other carbonates will be dismantled, they will be easily carried away. So even if the moderate rainfall occurs, these are the minerals which are going to get eroded or get washed away, rather not eroded, correct term is washing away, will get washed away very fast, very quickly. Then what is left behind? Higher concentration of silica, aluminium, higher concentration of iron. So we have higher concentration of silica, aluminium and a higher concentration of iron. Right? Now out of these two, aluminium and iron, which one will move faster? Which one has a higher chance of getting eroded? Silica. Right? Silica. Silica forms colloidal solution with water and is easily carried away. and is easily carried away. So what is left behind? Higher concentration of either aluminium or the concentration of iron, right? So in this case, the concentration would be higher, that of higher concentration of silica, aluminium, iron. Now silica forms a colloidal solution and gets washed away, then we have a higher concentration of iron or aluminium. So accordingly the name is given, right? How is it? How do we get the type of soil now? If the iron concentration is higher, which happens if the parent rock is a higher iron, it will give rise to the formation of red soils, or which is called as ferrosols. If aluminum concentration remains higher, then it is called as lateritic soils or latosols So there is a continuous washing away of minerals, although a lot of minerals get washed away, this particular process, to be very exact, because it's moving away of the silica from top layer, is called as desilication. The word is indicative, desilication. That means the silica is removed. Silica gets washed away. And what do we have high concentrations of? Either aluminium or iron. So now can I conclude from here and just go through your thought process and think, put pressure on yourself and think, those areas where the rainfall is higher, like equator, like coastal areas like Meghalaya and all these places, the soil should be soil should be lateritic type, because aluminium anyways has higher concentration than iron on the crust. So it will be having lateritic soils, laterization. But if the parent rock has higher iron content, like in Jharkhand, Chhattisgarh, Odisha, these areas, so if the parent rock has higher concentration of iron, then red soils. Then we have higher concentrations of red soil. So we have ferrosols there. Otherwise we have alphisols. Clear? So this is one case where moisture balance is positive with a higher precipitation. So this is how leaching can take place. Right? Removal of these minerals from the top layer, that can cause this leaching effect. Right? So let's remove this and now try to understand. Another process. Now we'll see those processes where the moisture balance is positive because of lesser evaporation. Right? Like polar areas. We're talking about places close to polar areas. What happens in polar areas, right? Ignore this humic content and so on. In this case, again, let's see the second aspect. We have silica, we have aluminium, we have iron, we have magnesium, we have calcium and so on. Now in this case, the precipitation is greatly high, exceeds evaporation. Not because the rainfall is very high, it's because evapotranspiration is very low. We have positive moisture balance because the evapotranspiration, the combined loss of water by the process of evaporation and transpiration is extremely low. That is what is the process of evapotranspiration. That is why automatically precipitation will be higher. Automatically the moisture balance is positive. Now in these cases, right, again, sodium etc. will be washed away. They will be first to go. Sodium, calcium, phosphate etc. They will be first to go. What is left behind then? Iron, aluminium, silica. Now out of all these three, iron, isn't it denser? So it will sink to the lower layers. Right? It will sink to lower layers. And in the lower layers, it forms this hard pan structure. Continuous deposition of iron will take place, and this hard pan like structure is formed in the B horizon. We'll discuss what is a B horizon. Right? Not to worry about it. But so explaining this, because here it is not washing away directly. It is not that everything is silica etc. get washed away, because the precipitation is not as high as 400 centimeters per year. It is just around 90 to 100 centimeters per year. But then evaporation itself is not there, transpiration itself is not there due to low temperature. So iron keeps on moving towards lower parts of the soil and settles down there. What is then higher? Silica is higher, aluminium is higher. Now the second turn will be that of aluminium. Now aluminium will start settling down, and the top layer will be rich in silica. And this higher silica concentration matlab it has higher acidic content. It has higher acidic content. It called as acidic soils. And the process is called as podsolization. Called as podsolization. And the types of soils are called as podsols. Acidic content is relatively higher. Humic content will also be higher, because in the previous case where the rainfall was very heavy, like 400 centimeter rainfall, a place like equator, even the humus gets washed away, even the organic content gets washed away, and we are left with just silica content. Right? So this is about podsolization in the areas where moisture balance is positive. Because evapotranspiration is very less, automatically precipitation is higher. In the previous case, we saw that leaching process. What is leaching process? Where the soils get continuously washed away, right? They get completely washed away, removing all the components. First the silica to go. It forms a colloidal solution with water along with other minerals and gets washed away. So what is left behind? Aluminium or iron concentration. But on contrary to this, right, if I see the next part, I suppose if I go to the previous discussion and let's see in the areas where moisture balance is negative. We have negative moisture balance. What about this case? What about negative moisture balance? If the moisture balance is negative, it's because evaporation or evapotranspiration is higher than precipitation. So the conditions understand the temperature is high. When temperature is high, evaporation or evapotranspiration rate is also very high. Moisture balance is negative. Then how will soils be behaving? What will be the types of soils and what is that process? Let's discuss this point now. Suppose I consider these layers as different layers, although we have O layer, A layer, E layer, B layer, all these layers, and evaporation or evapotranspiration rate is higher, right?